Hello class. In this lecture I will talk about how to determine sample size. So the first thing is there are three types as we discussed. One was z-stat. So this is used for mean calculations, and the main thing here is your standard deviation or variance is known. This is when you can use z-stat, and then your n is greater than or equal to 30. And then we have p-stat. So this is also used for mean, and this is when sigma is unknown. So when sigma is unknown, you kind of take a small sample and try to use the sample standard deviation instead of this sigma. So you replace it with s, and then your n is less than 30. And then finally we have proportion. So this is a different problem. So in this also you use z-stat. So based on this, we have a margin of error for each one of the areas, and we will use that margin of error to determine the sample size. So the first concept I will talk about is z-stat. When to use z-stat? This is when your n is no, this is when your sigma is known and n is greater than or equal to 30. So the formula for the sample size is z alpha over 2 multiplied by sigma. So this is multiplication over error whole square. So this is margin of error. So that's the formula. So that is for z-stat. So let's try to solve a problem on this. So calculate estimated sample size when confidence interval is equal to 80% and standard deviation is population standard deviation is known. So when I write sigma, that is population standard deviation. And this is equal to 4, and the error, margin of error or error is 0.2. So sometimes instead of giving you this 4, they will say variance. They will give you variance, which might be 16. Then you can calculate standard deviation by doing square root of 16, which is 4. So standard deviation is square root of variance. So sometimes they will give you variance, sometimes they will give you standard deviation. So the problem is like that. I will try to solve this problem by using the above formulas. So the sample size formula is n is equal to z alpha over 2 multiplied by sigma over error whole square. So in this all these are given, so let me, sigma is given as 4 and then error is given as 0.2, and the challenge at this time is to calculate this z alpha over 2, which is also called critical value. So to calculate z alpha over 2, we have discussed this in previous lecture that we need confidence interval, and the confidence interval is 80%. So the confidence interval, they gave it as 80%. So that means alpha would be 1 minus 0.80, that is equivalent to 0.20, but we wanted alpha over 2, so we will do so alpha over 2 would be 0.20 over 2, that's 0.10. So so we wanted to calculate z value at 0.10. So what this means is we have a normal distribution curve, and then this is negative z alpha over 2 and this is positive z alpha over 2, and this area is 0.10, this area is 0.10, and this area is 0.80. So since our z table gives left of the curve, so that is this area, so when we look at our z table we will get this value. So z at 0.10, we will go and download our statistical tables. So I will go to our canvas, go to module 0 and calculation aids, and in this I will go to statistical tables and open this statistical table. I will do enable editing. Now we will be going to sorry, we will be going to z table. So let's at this time we are in Poisson table, so we'll go to z table. So we go to z table and look for .10, so that's our probability. So this is our probability. So we go and look for our probability of 0.10. So 0.10. So 0.10 approximately, this is very nearer to it, or this one, so we can take one of them. So I will take maybe that's negative 1.28. so again you can take negative 1.29, so you can take any one of them. So I will take negative 1.28. So this value is negative 1.28, so this will be positive 1.28. Now I got z, this value negative 1.28, so I will just go and substitute that into our formula. So again, our formula for sample size is n, z alpha over 2 multiplied by sigma divided by the margin of error whole square. So z alpha over 2 is this value. So this is negative 1.28. This is the standard deviation is 4. So that's this is 4, and this is 0.2. So that would be negative 1.28 multiplied by 4 divided by 0.2 whole square. So once you calculate this, you will get 655.36, that is 656. So you need 656. So you always try to round up. So they will tell you round up in Hawks. So this is we need 656 samples to have to make a estimate about mean with a margin of error of 0.2. So that's what we are trying to say, determine here. So you can make an estimate of mean with an error of 0.2 and confidence interval of 80%. You need around 656 samples. So this is your n will be 656. So that is what we are trying to determine with this. Mostly your Hawks learning has problems related to this. I don't think we will discuss T also. First let me solve this same problem using calculation aids. Calculation aid. So you have, so let's see what's given in the question. So the question is the confidence interval is 80%, sigma is, the standard deviation is 4, and margin of error is 0.2. So confidence interval is 80%, and then what's next? Let me check. I keep forgetting these terms. So sigma is known, so, and it's 4. So that is population standard deviation is 4, and your margin of error is 0.2. So that is right. So let's go to our calculation aids. And so usually when sigma is known, you'll kind of use z value or z stat. So let's go and look at our calculation aids. So I will download chapter 9 calculation aids. We'll do enable editing. So this is currently we are in confidence interval mean known variance spreadsheet. We have to go to sample size. So most of your Hawk's learning problems are z value. I haven't come across anything with t value, but we will discuss it in case we will have one or two problems, and you might get those. If you get those, you can solve it. So this is your Hawk's learning will have most of these problems related to mean. So out of these two only I'm talking about. Proportions, there are problems. I found some problems on this. There are problems on this also in Hawk's. So population standard deviation, that is sigma. So in our question, population standard deviation is 4. So I'll go here, type in 4 in population standard deviation. This is 4. Again, alpha, I need to determine what is alpha. So I go here, they gave us 80% confidence intervals, so alpha would be 1 minus 0.80, that is 0.20. I go here and substitute alpha as 0.20, and then my margin of error, I think it's let me check margin of error, that's 0.20 or 0.2, so I will type in 0.2 and hit enter. So if you see, we got our critical value 1.28, and then our sample size is 656.94, so you can round it off to 657. So this is exact value because you say we took our z value 1.28 rather than 1.28, 155, 157. So that is sample size with z values. So in that you will have known standard deviation. So we will try to solve one more Hawk's learning problem. So because I wanted to teach all the 3 cases in one video, I will try to use, I copied Hawk's learning questions into Word document. So let's see the first problem. I think this is our z-stat problem. Sample size, we are trying to determine this. So the question is, we have a toy manufacturer wants to know how many new toys children buy each year. So assume a previous study found that the variance to be 4.41. She thinks the mean is 6.5 toys per year. What is the minimum sample size required to ensure that the estimate has an error of at most 0.1 at the 99% confidence interval? So they gave us variance here. So variance is sigma square. So this is, they gave us 4.41, and then they gave us mean, which is mu here 6.5, and then the error at most should be, so the margin of error would be 0.1 and the confidence interval is 99%. So that is what is given. So if you see our so this is again when they claim something, a previous study like that without a sample. So without sample, so if they don't give the sample size, without sample size, if they claim something, then you will be using Z stat. So if they give you sample size like 5 or 10, so this is n. If they give you this as 5 or 10, then you will be using T stat. So currently in this case, the first thing is I will again use this spreadsheet. So I will open a new one and then I will try to solve in that. So let's go to module 0, download chapter 9 and then open it. I will do enable editing, and this is we are in confidence interval mean non-variance spreadsheet, so we need to go to sample size. So the first thing is again we are dealing with mean with z values, so the sample population standard deviation is we need to determine. So I will go here. So this is they gave us variance. Variance is sigma square, so the standard deviation is sigma, so that would be square root of 4.41. So when you do square root, it will give you standard deviation. So square root, so usually the formula is standard deviation is equal to square root of variance. So square root of 4.41, let me see, what is this, square root of 4.41 would be 2.1. So that is our standard deviation. So you will do so you will use 2.1 for your population standard deviation. So I will go to my sheet and then population standard deviation is 2.1. So this is 2.1, and then alpha, I need alpha value, so I will go to my Word document and see what is alpha. So they gave us 99% confidence interval, so alpha would be 1 minus 0.99, that is 0.01. So alpha is 0.01, so I will go and key in that value. Alpha is 0.01, so that will hit enter, and then the margin of error. So margin of error is given as, let me see, 0.1. So margin of error is 0.1 and hit enter. So if you see, the critical value is 2.57 and you need 2925.9894 samples, so that is 2926. Okay, not this one. So let me, what's that, 2926. So this would be the sample size you need is 2926. So this is your n. So this would be your answer. So that is mostly with Z. So now if you wanted to calculate with T, the formula would be, again, this is Z, and now with T. So T is mostly T stat we use when n is less than 30 and sigma is unknown. So to obtain this sigma, we take a small sample and calculate S. So usually in T-stat, the difference between Z and T-stat, they will give you a N. So they will say N will be 10, but it will be less than 30. So usually they will give you, so this will be given. So they will say N is 10 or N is 5. So you just conduct a small preliminary study with a small size in T-stat, or they will say N is equal to 25. So this will be given. That's the major difference between Z and T. So the formula for sample size in T, so that is N. So again, T alpha over 2 degree of freedom multiplied by S divided by E whole square. So again, this degree of freedom is n minus 1, where this small n is the sample taken in a preliminary study. In a preliminary study. So that is this n which I was referring to. We take a small sample and then try to determine a bigger sample. So in this, you are kind of taking a smaller sample to make to estimate about a bigger sample. So these kind of problems, I don't think you will kind of find in your Hawk's learning, but we will try to solve one problem on this. I'll go to another document and look at how to solve T-stat formula. Again, this is T-stat. The first thing is you take n less than 30 small preliminary sample like 10, maybe even 4, and then since your sigma is unknown, you will use the standard deviation of that sample. So you will take this 4 or 10 small sample size and determine what is the sample standard deviation and use that. So the formula would be T alpha over 2 degree of freedom multiplied by S divided by E whole square, where this is degree of freedom is n minus 1. and this is margin of error, how much error you are estimating at max, and then this is sample standard deviation. So we will try to solve a problem on this. So this is an example problem, and I couldn't find any problems in Hawk's learning related to this. So you can kind of if you find something like this, you can solve it. So the question is, calculate estimated sample size when confidence interval is 90% and margin of error is 0.3. So in this, as I said, we will have a preliminary sample. So a preliminary sample of 10. So you see they specified the sample size here. So if they specify this, then you are using T stat. So of 10 is taken and the mean is 8. Usually they will give you mean, but we don't use mean in the formula. And then the standard deviation is 4. So that's okay. So what all is given? So they wanted us to calculate 90% confidence interval. So this is given, and then they wanted our margin of error is 0.3, and then this preliminary sample is taken, which is 10. So that is this. So this is what distinguishes Z and T. So in Z they won't say the sample size, so there will be in Z this won't be there. So the sample size here is 10 and the mean of that sample x bar is 8, and the standard deviation of that sample S is 4. So we can just use this formula and see if we can do this problem. So we have n is equal to the formula is n is equal to T alpha over 2 degree of freedom multiplied by S divided by E whole square. So given is E is 0.3, S is given, which is 4, and then we have to determine this part. So what is this? This is critical value. So to help us to calculate T alpha over 2 degree of freedom. So for alpha over 2 they gave us confidence interval. For degree of freedom it is n minus 1. So our sample size is 10. 10 minus 1, so 9 is our degree of freedom. Confidence interval they gave us 90%. So you need to calculate alpha over 2. So you know alpha is 1 minus 0.90, that is 0.10. Alpha over 2 is 0.10 over 2, that is 0.05. So we are looking for a value T alpha over 2 degree of freedom, that is T alpha over 2 is 0.05 and degree of freedom is 9. So we will go and look for in T table this. Okay, this is T table, this value. So again, what this means is we have this normal distribution curve. Let me see. We have this normal distribution curve, and then this is T 0.059. so that will be, so always T table is going to give right of the curve, so it is going to give me this point. So I wanted both sides, so this is this point is negative T 0.05 and 9. So this probability would be 0.05, this probability would be 0.05, both of them together would be 0.10, and this in between would be 0.90. So that is our confidence interval, 0.90. So I can go again, this is T 0.05 comma 9. I can go into my T table. So I will go again to statistical tables, download statistical table, and then go to, currently I am in Poisson table, so I will go to T table. So this way is degree of freedom, so the column, these represent degree of freedom, and these represent these values T alpha over 2 or T alpha, whatever, and later on we will talk about it. It's we might use T alpha over 2 or T alpha. So at this time T is T alpha over 2, so we are looking for T 0.05 with degree of freedom 9. So I will go to the T table, and then T 0.05 is this one, and degree of freedom 9 is this one, so my value would be this 1.8331. So I will go, so this would be so this is the value I got, 1.8331. so this would be negative 1.8331. so this is 1.8331. so I will substitute that value into our formula. So again, our formula is n T alpha over 2 degree of freedom S over E whole square. So this is so this is 1.8331. S is given as so let me check, S is 4 and E is 0.3. so S is 4, E is 0.3. so I will just, this is 4, this is 0.3. so our formula would be 1.8331 multiplied by 4 divided by 0.3 whole square. So this is going to give us 597.37, which is approximately, I will round it off to a higher value, 598. So I need 598 samples. So my new n, maybe my new n would be 598 to make a meaningful conclusion about the data, about the mean of the data. So I can use the same for problem using and solve it using calculation aid. So we are given, so this is what is given. So our question says, again I will go back to the question. Let me see. Okay, here is our question. So confidence interval is 90%. Margin of error is 0.3. So let me note down these values here. So confidence interval is 90%. Margin of error is 0.3, and then sample size n is 10, x bar is 8, n is 10, x bar is 8, and then sample standard deviation is given as 4, I think. Let me go. Yeah, it's 4. So this is 4. So this is, now we are using, you see, with let me the first thing is we have a sample size n less than 30, and then our sigma is unknown, so we took a sample to get this value. So we will be using t-stat. So this is case 2. We will use case 2 in our calculation aid. So I will go to our calculation aid. I will try to download a new one. I will do enable editing. And then currently I am in confidence interval mean known variance. I will go to sample size, and again I am going to use, now I will be using case 2, which is mean with t value. So the first thing in that is a sample standard deviation. So sample standard deviation is what I need to determine. I will go to our problem and look for sample standard deviation. Sample standard deviation is given as 4. So I will type in 4. So this would be kind of, let me say it's 4. And then you see sample size, the difference between case 1 and case 2, we have a sample size. So what is our sample size? Our sample size is our sample size is 10. So I will go here and I will use sample size of 10, and then alpha, I need alpha here. So let me check what would be my alpha. my alpha, my confidence interval is 90, so alpha would be 1 minus 0.90, that is 0.10. So I'll put an alpha of 0.10, and the margin of error, I need to check what is our margin of error. Margin of error is 0.3. So I will go to this sheet and then type margin of error 0.3 and hit enter. So that is, it's going to give us a critical value which is 1.83 and 598 samples. So this is again an exact value, 598 samples we need. So the answer for this problem would be 598. So n will be 598. So this is our answer. So finally, I wanted to discuss about the last part, which is proportions. So how do you calculate sample size for proportions? So I will do sample size for proportions. So this is the formula for this is n is equal to z alpha over 2 divided by the error whole square multiplied by p hat 1 minus p hat. So again, this is p hat is sample proportion, this is margin of error, and this z alpha over 2. So this one would be critical value. So that is the formula. So we'll try to again look into a problem on this. So this is an example. So example, I don't know why this is, let me check. Yeah, so this is the example problem. So let me use I think there's something weird is happening. Example, maybe I'll use a new sheet for this and try. Okay, so this is again sample size for proportion. I'm sorry for that. Sample size for proportion. So the formula which I gave, I'm writing it again because something weird happened. So this is n is equal to z alpha over 2 by e whole square multiplied by p hat 1 minus p hat. So p hat is the sample proportion. This is margin of error, E is margin of error, and then Z alpha over 2. So that value, that is this Z alpha over 2 is our critical value. So I will try to use an example. The example, okay, so example is p hat is given as 0.42, and then error is, margin of error is 0.3, and confidence interval is 99%. So what is our n? So again we use the formula. Our n formula is n is equal to Z alpha over 2 by error whole square multiplied by p hat 1 minus p hat. So this part, so error is 0.3, p hat is 0.42, and I wanted to calculate this. So what is this? That's mostly you know that it is critical value. So for Z alpha over 2 they gave us confidence interval. So they are saying confidence interval is 99%. So alpha would be 1 minus 0.99, that is 0.01, and then alpha over 2 is 0.005. So that means we have a normal distribution curve, and then we have, this is negative Z alpha over 2 and this is positive Z alpha over 2. So this whole area is 0.99. So this plus this together would be 0.01. So this, only this would be 0.005, and only this portion would also be 0.005. So let's go to Z table. So I will go to Z table and look for the probability of 0.005 and see what value I will get. So I will go to my Z table. So this is probability. So I will go to my Z table. Let me download statistical tables. So I go to statistical tables, and then I'm in Poisson table, so I need to, I'll do enable editing first, and then I'm in Poisson table. I will go to Z table. So that's the Z table spreadsheet I went. So I'm looking for, so this is to the left, this table gives to the left of the normal distribution curve. So I'm looking for 0.005 probability. So 0.005 is this or this. So negative 2.67 or 68. So negative, okay, this is, oh sorry, this is wrong. This is negative 2.57 or 58, not 6. So negative 2.58 or 57. So I usually take even numbers. So again, this is that's my preference. You can take 57, negative 2.57. So let me go and look at. Okay, so let me go and see this. This part is negative 2.58 and this will be positive 2.58. So I will substitute those values into our formula. So our formula is n is equal to z alpha over 2 divided by e whole square multiplied by p hat 1 minus p hat. So this is z alpha over 2, I got negative 2.58 divided by error is 0.3. So error is 0.3 whole square multiplied by p hat is given as 0.42 multiplied by 1 minus 0.42. So this is I'm going to get, if I calculate this, 17.87. that is, I will round it off to the next integer, which is 18. So I need 18 points, 18 sample 18 data points to make any meaningful conclusion about the proportion. So let's again solve this problem by using calculation aids. So let me check. So let me open up, let me see. So what are our values? Let me see. We have a p hat of 0.42. So I will do, so this is, we are using calculation aid. P hat is 0.42 and then margin of error is 0.3. This is 0.3 and then confidence interval is 99%. Confidence interval is 99% and they are asking us to determine what is our n. So I wanted to go into my calculation aids. So I will just download a new sheet. I'm downloading new sheets every time because it's difficult for me to work on the same spreadsheet while videotaping. So I'm trying to adjust to this new mode. So I will do enable editing and then I go to sample size. Now this is a proportion problem, so that means I will be using this case 3. So proportion, so let me see what is the proportion given. So I will go to our sheet and look for proportion, which is 0.42. so that is sample proportion 0.42. I will type in 0.42 here and alpha, let me check what is my alpha. So they gave us 99% confidence interval, so alpha will be 1 minus 0.99 which is 0.01. So alpha would be 0.01, and then the margin of error is given as 0.3. So I'll go, so margin of error is somehow margin of error, let me type this, I somehow deleted alpha. Margin of error is 0.3 and alpha is I think it is 0.01, 99% confidence interval. So let me cross check alpha. Okay, alpha is 0.01, so here alpha is 0.01. So our answer is like we have a critical value of 2.57, and then our answer would be 17.95, which is 18. So this would be approximately 18. So that's how you will be solving proportions problem. So I will again try to solve one more Hawk's problem on proportion before concluding this lecture. So I will go to, so I copied this from Hawk's Learning to the Word document. So I have a state education commission who wants to estimate the fraction of 10th grade students that have reading skills at or below 8th grade level. In an earlier study, the population proportion was estimated to be 0.17. So they gave us proportion, which is 0.17. And then how large a sample? So what should be the sample size? If we would be required to estimate the fraction of 10th graders reading at or below 8th grade at the confidence at the 90% confidence level. So confidence interval is 90% and error of at most 0.02. So these are given. So I will just type in and try to get the sample size. So proportion is given as 0.17. So I can go here and type in proportion. So that is 0.17. And then I wanted alpha. So for alpha they gave us confidence intervals, so alpha would be 1 minus 0.90, that is 0.10. So I will go and type in 0.10. So let me see where I'm working on. Okay, so this is alpha is 0.10, 0.10, and the error, margin of error. Let me see what is the margin of error I have. Margin of error is 0.02, so I go and type in margin of error 0.02. Let me check, it's 0.2 or 0.02. Margin of error is 0.02, so that is 0.02. So my answer is the critical value is 1.644854 and the sample size is 954.38, so this will be 955. So that's how you will be solving these problems. This concludes my lecture on determining sample size. Thank you.